Well, hello, Mr. Eicher here. We're going to do a review of the different types of chi-squared tests that we've learned in this chapter. Do a couple practice problems. So let's get started. So we have three chi-squared tests: goodness of fit, homogeneity of proportions, and then a chi-squared test for independence. It could also be called chi-squared test for association. So when is each test appropriate? So a goodness of fit test is when you have one categorical variable in one population, or you've only taken one sample, one variable, one sample, one variable. For a chi-squared test for homogeneity, you have one categorical variable in two or more populations or groups. So this would be maybe two or more groups in one variable, in other words. Experiments are often in this category, a chi-square test for homogeneity. And then lastly, a chi-square test for independence. You have two categorical variables in one population, or this would be one sample is taken and two variables are measured. Another way to tell is if you have a one-way table, that would be goodness of fit. Either of these would be two-way tables. Some statisticians don't make a big deal about the difference between homogeneity and independence, but we do in AP Stats. So there's the differences. To calculate the expected counts, for goodness of fit, it is the expected count equals n times p, where that p is p sub I, little subscript there, an I, which whatever cell or category you're on. So n times p. If it's a uniformly distributed goodness of fit test, then all those proportions would be the same percentage. If it's not uniformly distributed, kind of like the Skittles or M&M example, then those proportions will be different and it matches whatever color Skittle it is, 20% or 15%, so the p's could be different there. For the expected counts for both of the two-way table chi-squared tests, the expected count for a particular cell is the row total times the column total for that cell divided by the table total. And that's true for both of the two-way table expected count formulas. Next we have degrees of freedom. Degrees of freedom for a chi-squared goodness of fit test. Degrees of freedom is the number of categories you have minus 1. You could also see this as n minus 1, but I don't really like using n there because n, we often think of sample size with n, so I'd rather put like number of categories minus 1 rather than n minus 1. Degrees of freedom for both of the two-way table tests are the same, so it's going to be the same formula. The degrees of freedom is however many rows you have minus 1 times however many columns you have minus 1. Or maybe we could do r minus 1 times column minus 1. And that's the same formula for both. And then finally, the test statistic itself is the same formula for both. Chi-squared, chi is a Greek letter, looks like an X, cursive looking X. Chi-squared is the observed count minus the expected count squared. Then it's weighted or divided by the expected count. You do that for every single cell, and then you sum that up for all the cells. And that would be our chi-squared test statistic. Remember, chi-square is a right skewed distribution, like that. And chi-squared is this boundary. The p-value is always greater than chi-squared. And to find that p-value, we could use chi-squared CDF. We have lower bound, upper bound, and then the degrees of freedom. The upper bound in this type of function is always infinity, since it's right skewed. We're always pointing to positive infinity. And the lower bound is always chi-squared, so we could put those in there. So all of this would give us the p-value. and the degrees of freedom depends on the context and what type of test you're running. So that's a summary of the 3 different chi-squared tests that we have. So I'd encourage you to pause this video now and for the following situations decide what type of chi-squared test is appropriate. Number 1, 2, and 3. Go ahead and pause the video and see what you can do. So probably the first thing to observe, for instance, in number 1 and number 2, we have what are called two-way tables, whereas in number 3, we have a one-way table. We just have this one variable here, the color. So this is a one-way table. That narrows it down that number 3 must be a chi-squared goodness of fit test. Goodness of fit. We have one sample, we have a single random sample, and we have the color is our one variable. So we have one sample and one variable, one categorical variable, and that's color. Between the two up at the top, to determine which of the 2 chi-squared tests for two-way tables we should use, the question is how many random samples were taken. On question A, we have separate random samples, whereas on question, that was question 1. Question 2, we have a single in the single sample. So even though they're both two-way tables, however the data is collected is how we determine if we should use a chi-squared test for homogeneity or a chi-squared test for association. So because we have separate random samples from store A and store B, really the one categorical variable that we're actually measuring is gender. So we have 2 samples with one variable. So that would be a chi-squared test for homogeneity or homogeneity of proportions. The next one, we have a single sample, and we're interested to see if these 2 variables are associated, opinion about astrology and the degree held. So we have 2 categorical variables that we're interested, are they associated within this one sample? So that would tell us that we should use a chi-squared test of association. Is there an association between these 2 variables, or are the 2 variables independent of each other? So a chi-squared test for independence. Last question I'd like to look at is this one. Go ahead and pause the video and read the context we have. And if you'd like to try to answer some of the questions like A or B, you can go for it. So what this question is getting at is the information in the newspaper didn't really tell us how the data was collected. So it isn't really possible to know which chi-squared test is appropriate. We can narrow it down to 2, but on questions C and D, we'll talk about how would the data need to be collected to be that appropriate type of test. So first, question A, why is it okay to use age as a categorical variable rather than a quantitative variable? Typically, ages are numbers, and you can average them. But in this case, we have the ages are in ranges or categories like 18 to 24, which then we count how many are in each category. So as a count, it becomes a categorical variable, which we can find proportions with and things like that. Question B, explain how you know that a goodness of fit test is not appropriate. We have a two-way table, and goodness of fit tests are typically one-way tables. So as a two-way table, that narrows it down to either a test for association or a test for homogeneity. And then questions C and D, describe how these data could have been collected so that a test for homogeneity is appropriate. D is describe how these data could have been collected so a test for independence is appropriate. Remember, a test for homogeneity is 2 SRSs in one variable that we're analyzing, whereas a test for independence is 1 SRS, one group, one sample, with 2 variables that's collected. So if we had 2 SRSs in one variable, 2 or more, I could say, 2 plus SRSs, they could take a random sample from each age group. They take a random sample from each age group. That would be 6 separate random samples. And then they ask one question. They ask, do you use social networking sites online? So we could say if they had 6 separate random samples from each age group, one from each age group, and asked one categorical data question, do you use online social networking? If they did it this way, then a test for homogeneity would be appropriate. You have 2 or more simple random samples with one categorical variable. They could have also done it the other way. They could have taken one random sample of those who use social networking and then asked one categorical variable, what age group are you in? And then a separate simple random sample among those who do not use online social networking programs, and then ask their age group. And then lastly, how could these data have been collected so that a test for independence is appropriate? This is probably what they did. I can imagine they take one simple random sample. They take one simple random sample and ask 2 categorical data questions. They ask their age and they ask their social usage. Again, that's probably what they did. They're probably going to take one random sample and then ask someone's age and ask, do you use social networking? It would be pretty difficult to do it this way, to take 6 separate random samples from different age groups. You'd have to know the person's age, which would be a question for them, a categorical data question, what's your age? So again, they're probably looking to see, is there an association? Is there an association between age and someone's usage of social media? Thank you for watching this video. I hope that fleshed out a little bit more the differences between the 3 chi-squared tests: goodness of fit, homogeneity, and association. Thanks for watching this video. See you next time.